Hi everybody and welcome to the video. My name is Sierra Baldwin and I'm a physics undergraduate at Michigan State University. Today I wanted to talk about a problem from chapter 2 of the second edition of thermal physics by Kittel and Kroemer called the meaning of never. This problem is pretty self-contained, so we'll just start off by reading through it together. So the meaning of never. It has been said that 6 monkeys set to strum unintelligently on typewriters for millions of years would be bound in time to write all the books in the British Museum. This statement is nonsense, for it gives a misleading conclusion about very, very large numbers. Could all the monkeys in the world have typed out a single specified book in the age of the universe? Suppose that 10 to the 10 monkeys have been seated at typewriters throughout the age of the universe, 10 to the 18 seconds. This number of monkeys is about 3 times greater than the present human population of the Earth. So a lot of monkeys. They're really grinding. We suppose that a monkey can hit 10 typewriter keys per second. A typewriter may have 44 keys. We accept lowercase letters in place of capital letters. Assuming that Shakespeare's Hamlet has 10 to the 5th characters, will the monkeys hit upon Hamlet? And the first part of this problem says to show that the probability that any given sequence of 10 to the 5th characters typed at random will come out in the correct sequence, the sequence of Hamlet, is of the order of 1 over 44 to the 100,000, which is equal to 10 to the negative 164,345. Okay, so this first part is actually just a basic probability problem, but this can be kind of hard to conceptualize with such large numbers, and all the image of these endlessly grinding monkeys you now have swimming in your head. So let's break it down into something more simple or familiar. Let's take a coin. We know that if we flip a fair coin, we have a 50-50 probability of heads or tails, or fractionally, 1/2. Now, if we flip that twice, what's our probability of getting 2 heads? Well, that's just 1/2 times 1/2, or 1/2 to the 2. If we flip a coin n times, where n is some arbitrary number, we can express this probability as 1/2 to the n. Likewise, if we have 44 keys, right, instead of 2 options, we have 44, our probability of hitting the right key is 1 over 44. Now, we have to hit the right key 10 to the 5th times to get Hamlet, so our probability of any given sequence coming out to be in the sequence of Hamlet is just 1 over 44 to the 10 to the 5th. But this number is kind of confusing, so we'll simplify it a little bit. Logarithms can be a pretty handy tool to simplify powers. So to better conceptualize this number, we'll use this handy property of logarithms shown on screen. And for those just listening, this is a to the x is equal to 10 to the quantity x times log base 10 of a. Since we're given that log base 10 of 44 equals 1.6435, we know that we can rewrite this number as 10 to the negative 164,345. So we did part A. Good job. Now let's move on to part B, which reads as follows. Show that the probability that a monkey Hamlet will be typed in the age of the universe is approximately 10 to the negative 164,316. And okay, so I have a side tangent here about how long the age of the universe actually is, because this is a hard number to conceptualize also. There's a pretty commonly used analogy that goes something like, if the universe is history as we know it were compressed into a single year, the entirety of human existence would only span about the last few seconds of the last day of that year. So the age of the universe is a really long time for these monkeys to be typing. Just putting that out there. We're going to start with the age of the universe, and we're going to multiply that by the rate of typing to get how many characters that one monkey types. And then we want to multiply this by our number of monkeys to get the number of Hamlet-length manuscripts that the monkeys will produce. And we'll call these possible Hamlets. Numerically, this comes out to be 10 to the 29th. And then we can use our answer from part A, which was the probability that Hamlet-length manuscript is actually Hamlet, and multiply that by our possible Hamlets to get the total probability that a monkey Hamlet will be typed in the age of the universe. And this comes out to be 10 to the negative 164,316, which is an incredibly small number. So the authors then assert that the probability of getting a Hamlet is therefore 0 in like any operational sense of the event. So the next time that your friend tells you that monkeys can type Shakespeare, you can be a total buzzkill and tell them no, and exactly why not. Awesome. So that's all I have for today. Thank you for watching. Bye.